Alright, today you're going to be learning how perimeters and areas of similar figures can be calculated. So when we're talking about perimeters of similar figures, when two figures are similar, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So the perimeter of triangle ABC, the ratio of that to the perimeter of triangle DEF is equal to the ratio of side length AB to side length DE, or side length BC to EF, or AC to DF. So in example 1, the height of figure A is 9 feet. The height of a similar figure, B, is 15 feet. What is the ratio of the perimeter of A to the perimeter of B? So always start by writing down what you're looking for. So we want perimeter of A to perimeter of B. And what our key idea told us is that when the figures are similar, the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So we can find some side lengths, and it tells us the height of A is 9 feet, okay, and the height of B is 15 feet. So the perimeter of A, the ratio of the perimeter of A to the perimeter of B is equal to 9 to 15. And remember that we could simplify that. We could write that in simplified form if we divide out a common factor. So 9 and 15 both have a common factor of 3. So if we divide top and bottom by 3, we can say that the solution is 3 to 5. The ratio of the perimeter of A to the perimeter of B is 3 to 5. So what about the areas? The area, when two figures are similar, the ratio of their areas is equal to the square of the ratios of their corresponding side lengths. So you can see that the ratio of area of the triangle ABC to the area of triangle DEF is equal to the ratio of AB to DE and that whole quantity squared, or BC to EF and the whole quantity squared, or AC to DF and the whole quantity squared. So the base of triangle P is 8 meters, and the base of similar triangle Q is 7 meters. What is the ratio of the area of P to the area of Q? So again, start off by writing down what you want to find. Area of P to area of Q. So the way that their ratios are set up, you have to put the first one in the numerator and the second one in the denominator. Since we are given the base of triangle P, we know that side length, whatever it is, so we know that we're going to have 8 to 7 and the whole quantity squared. Well, that's going to be equal to, when you have this whole quantity squared, you have 8 squared over 7 squared. Each of these have to be squared. So you have 64 to 49. And then, we can change it to a mixed number, but we really don't want to, because that kind of blurs the lines when we're talking about the side lengths. You've got to keep them as distinct, discrete numbers. So the ratio of the area of P to the area of Q would be 64 to 49. So we can set up what we know and relate the fact that our perimeters are equivalent to the ratio of the side lengths to find a missing quantity. So what we're going to do, it says the swimming pool is similar to the shape of a volleyball court, and you can see the picture there. So the swimming pool has a width of 16 yards, no other dimensions on it. The volleyball court has a width of 10 yards, but we're given the area of the volleyball court and we're given the perimeter of the volleyball court. So we're going to use what we know between these two figures. So since they're similar, we know that the perimeter of the pool is the ratio of the perimeter of the pool to the perimeter of the court, you know, is going to form a proportion, or we can make a proportion based on the side length. So for the perimeter part, so let's just write this down. So for the perimeter part, okay, we know that the perimeter of the court to the perimeter of the pool will be equal to, and then the width of the court and the width of the pool. Okay, so we're given those numbers. So they're equivalent to the side length, or the width of the court and the width of the pool. So let's fill in the information. We know that the perimeter of the court down here is 60 yards. We don't know the perimeter of the pool, but the width of the court is 10 yards and the width of the pool is 16 yards. So through cross multiplication, 16 times 60 is 960. 10 times p is 10p. So we could divide both sides by 10, and we would come up with 96 yards is equal to the perimeter of the pool. Okay? But we also need the area. So we're only halfway done with our calculation. So we have the perimeter is equal to 96 yards. And this is for the pool. I'm going to go ahead and erase that. And so we'll summarize. Perimeter is 96 yards. Now we can do the same for the area. We know that the area of the court to the area of the pool will be equal to the square of the ratio of the court to the side length of the pool. Okay, so we know the area of the court is 200. We do not know the area of the pool, but 10 times 10 is equal to 100, and 16 times 16 is equal to 256. So through cross multiplication, 100A is equal to 200 times 256, which is 51,200, and we'll divide both sides by 100. So we'll get the area of the pool to be 512 yards squared. Note that the unit length is squared in this one too. So the perimeter was 96 yards, and the area is 512 yards squared.